اوكي شوفك ده. الو رضوان, can you hear me? Okay, okay, can you see the picture and the sound, right? You can hear me and you can see the screen. Okay, thank you, Erdogan. All right. Okay, so let me go back a little bit. We had some internet issue. Okay, so for the 2.5 ml lyse syringe assembly, here they are controlled by the same motor, okay? But we have one of them is different, not the same volume. So we have the short white top. The short white top, this is for LEU2 injection, and the long one is for LEU1 and LH lyse. Okay, so different part number. Be careful about this when you remove and maintain. This is the vacuum pump, and this is the pressure pump. We have a pressure jumper to store and stabilize the pressure, okay? And we have also the vacuum chamber for waste collection and vacuum creation. Liquid valves, okay, we have a normal or generic valves and the LVM for high precision valves. Diluent filter and the waste filter, okay? This is the laser assembly or the optical system on the top. Sampling drive, okay, horizontal and vertical. This is the mixing assembly, the tube mixing assembly. And this feature also only available for the auto loading part, okay? For the manual part, you cannot mix it. You need to mix it manually. Diff bath, WBC and RBC counting bath. As you see here, they are shielded. We use here a Faraday cage, isolated, because here we use the impedance principle. So it is very sensitive to electrostatic or to interference, okay? Because the impulse size are very small, okay? So it is easily interfered. This is, we use a pinch valve here, just below the bath, the diff bath. Okay, later we see, when we reach the fluidic system, we see its purpose. Okay, this pinch valve, it's not pneumatic, it is a solenoid. Okay, it is a solenoid valve, but it is a pinch, okay? Vacuum chamber, waste pump assembly, and this is the preheat bath of diluent. Okay, so for the sampling assembly, okay, what do we have? The difference, of course, for the structure or for the movement of the sampling drive, for the RBCS, for both analyzers, for both models, WBC also, diff, but for the auto loading, of course, it is only available for the 5380. Closed tube also available for 5380. OV not available, okay, because here we use cap pierce. But of course, in the closed tube position, you can use a tube without a cap, okay, without any problems. Okay. So we have a probe wipe, sample probe horizontal motor, okay, driven by a belt, and this is the vertical. Okay. So for this, as you see here, it's pierced from the side, okay, or the hole is from the side. The lifetime, normally the theoretical lifetime is 27,000 piercing times, or 27,000 cycles, okay? There is a counter, software counter in the software. When the analyzer reach this number, it will give you the prompt, replace the sample probe, okay? This is very important, guys, because here you can initialize the counter without replacing the probe, but it is not recommended. Okay, because with time you will lose this cap pierce function. Okay, it will lose the ability to pierce the tube. Okay, so you will get very frequent partial aspiration error because of this. Okay, so make sure to replace in time. This is the mechanical, this is the mixing assembly. Okay, it has a lot of movement. Okay, so we have this movement. Okay, we have the up and down movement, and we have the rotation movement for the mixing. Okay, like that. This is for the mixing rotation. Okay, and we have up and down. This is the mixing motor. Okay, it's just tube pressure. So when actually this one comes and take the tube here, okay, take it back, go up and start rotating to mix. Okay, so for the vertical, we have the Z direction motor and sensor and start sensor for the Z. This is for the vertical movement, and this is for the X movement. Okay, or the horizontal, we have X direction and start sensor, and also the motor. And for 7 and 8 are for the mixing. Okay. This is the sensor status from the software. You can actually see all the sensors, okay, from the software. This is the diff bath assembly. Okay. This one, it contains this one do not have any maintenance to do on it. If some problem related to the temperature or leakage or any related problem, you need to replace directly. Okay, this is not a modular design. You just replace directly. There is no maintenance inside. So this has its own resistance inside to preheat the bath, because the temperature is very important for the reaction, for the lysine reaction. Okay, if the temperature is too high, then it will affect the internal, especially the internal complexity of the cells. If it is too low, then of course it will delay the lysine process. Okay, as we know that the timing sequence or the lysis sequence is limited, so by the time we'll send the sample to the flow cell, maybe some of RBCs are not lysed entirely, so we will get so much ghost. Okay, so this is the LEO1 injection, LEO2 in. Of course, here it will not go directly injected inside. Okay, it has a longer path to allow it to preheat. Okay, this is the WBC bath. It is just like a normal bath, normal bath we use in the 3D for something. It is the similar principle. Okay, here we have the hemoglobin assembly here attached to the bath, and this is for the RBC bath. These are isolation chambers below the bath. We have two. Okay, this is the pinch valve. Okay, actually before we had a very high failure for this valve due to some main reason, due to some liquid spillage. Okay, but now we get another new type of this pinch valve. It is more robust, and we added also protection like a sheet, metallic sheet. Okay, so this is a pinch valve but powered by a solenoid. Okay, this is the preheat bath. Okay, this is the preheat bath for the diluent, and this is the temperature sensor. All right, for the optical system, it is not very complex. Okay, so let's start here. Of course, guys, for the optical system, there is no mechanical adjustment needed for this model. Okay, or for this optical assembly. Okay, you can only replace some specific parts, like the SS diaphragm assembly, how you say, like the SS photodiode assembly or FS. Maybe you can change laser control board and so on. Okay, that's it. But for the mechanical components, the lenses, you do not touch. Okay, so we have, this one is our laser. Okay, and this is the laser. This we call the front optical assembly. This is for collimation of the light. This is our flow cell, and this one is the rear optical assembly. Okay, this also contains lens for signal adjustment for the light signal. Okay, this one is just a splitter. Okay, this is light splitter assembly that allows the light to pass in both direction. So here the light will go this direction and also this direction. Okay, this is the splitter, this one. And here what do we have? We have the FS diaphragm assembly, okay, to reduce the incidence light. And here we have the photodiode to detect the FS scatter. All right. For this one, for this side here, also we have the diaphragm to reduce the incident light, and we have the photodiode of SS of the side scatter here. Okay, this is just a switch. This is a switch to protect. Sorry, this is a switch to protect the user from exposing to the laser. So the moment you open this one, the laser will turn off. Okay, this is the laser control board. Okay, so here we use the red laser 670 nanometer. Okay, we have the collimation lens. So this is, all of this is what we call the front optical. Okay, front optical assembly, and this one is the back optical assembly, the backwards. Okay, so what do we have here? We have the laser collimated lenses. You see, it will collimate my signal. This is the cylindrical lens A, cylindrical lens B, and here we will focus the signal on the flow cell. Okay, so here we will converge it. Okay, and here we'll divert the signal using the posterior collimated lenses. This is the light splitter, and then we will focus the laser again on the photodiode. Okay, and also here the same thing. We'll focus before we enter the SS detector. All right. So for the forward optical assembly, to summarize, generate an elliptic facula to irradiate the blood cell in the flow cell. Okay. So here the diameter is 13 micrometer. Why I need this? To make sure that my cell, to make sure my cell will be hit entirely by the laser. Okay, so this is the laser facula. As you see, it will be more than sufficient to hit the cell. So here for the vertical direction, cover entire blood cell. For the horizontal direction, wider than that of the sample flow. Even light intensity in detection area. This is, sorry. All right. So this is for the front view, the focus point in the flow cell. And this is for the top view. So you get elliptical shape. This is the flow cell assembly. We have the sample injection here. This is the sheath fluid injection here. Okay. This also, in case of clog or some issue with it, you need to replace the whole optical assembly. Okay, so as you see here, this is my laser facula. This is the backward. Okay, block the direct light and then collimate. This is the splitter. We split the light. This is the diaphragm. Okay, this is just to reduce the incident light. Okay, block the scatter light at certain angle and then focus the passing light into the photodiode assembly. Of course, they are different. This is the SS and this is the FS diaphragm or mask. In some other models, we call it the mask. This is photodiode assembly, just like normal photodiode. Okay, it converts light into electrical signal. Okay, guys, do you have question about the mechanical system? Okay, we have 11 online here. Do you have some questions, guys? Andrei, do you have a question? Sergey. Guys, remember to sign the attendance sheet, okay, so that I can validate the field course for you on your SF Cloud account. So far, I didn't get any. Okay, 7. Okay, good. Okay, guys, let's continue. Okay, thank you, Isa. Okay, let's see now the installation steps. Okay, but of course, this is just will highlight only the main points. Okay, but for the installation, you need to follow the service manual or the installation manual, the PDF version. Okay. Okay, so of course we need the tools, controls, and calibrators. 7 micrometer standard particles. I'm not sure if they are still available to purchase or not, but here you can use the BC5D to verify or to adjust the FS and SS gains of the optical assembly. Okay, now you can do it with the BC5D QC. Okay, so for the space requirement, for the power requirement, of course, very, very important to ensure that we have a good ground. Otherwise, you will have so many interference with the impedance channel. This is for the environment temperature, for the environment requirements like temperature, humidity, and so on. For the computer, okay, no, normally now you can get much better than these specifications. Okay, you can get with Windows 10 directly now. It is available. It is compatible with Windows 10. Okay, this is a little bit older, the PPT, but no worries about it. You can install directly Windows 10. Okay, and then must have 2 partitions. Okay, leave C for the Windows and Windows application, and D leave it only for the Mindray software. All right. Of course, if you need to connect the analyzer to the LIS system, and here you cannot connect it directly from the analyzer, but you need to connect first the analyzer to the computer through network card, let's say number 1, and then from the software, from data management software of the analyzer, you connect to the LIS software through another network card. Okay, for the tubes, these are the tubes required or supported. Okay, anticoagulant collection tubes, ADTR. All right, all of these tubes are how do you say, are supported. All right, tube for pre-diluted mode, 1.5 ml centrifugal tube. For the barcode level, Here, pay attention to or train the operator to well stick the labels, because this model doesn't support the rotational barcode scanning. Okay, in some other models, let's say the BC-6000 or the BC-700 series with autoloader, they support the barcode rotation. Okay, so here make sure to correctly install the label like that, not like this, not like that. Okay, so unpacking the main unit. Okay, remove the belt, the binding plastic belt. This is the accessory kit. Okay, you remove the packing bag, packing list. You can check the machine if all the accessories are there. No accessory is missing. Okay. Here we remove the plastic tie to secure to release the sampling assembly. All right. So we just remove the plastic tie. Remove this paper clips or fixing to release the synchronous belt for the horizontal movement. This is also adhesive tapes. You remove them. Connect the network cable to the computer. Connect the power source. Here you connect the reagents and the waste. Okay. Each reagent has its own color, so you will not make any mistake. So diluent, you have LH lyes, LEO2, and LEO1. Okay, this is for the diluent. Okay, make sure to be perfectly perpendicular. Otherwise, it will give you an alarm that it is empty before the actual situation. Okay, so from the software site, it's easy. After you download, you set up, click on setup, follow the steps, choose your local language, and you will install it normally. Here, you select to make sure to select the right analyzer type. Okay. Here, always installing D partition separated from the Windows partition. If you do not have D partition, you just partition the hard drive with Windows Partition Manager. Okay, when it is installed, here the IP address settings, make sure to be in the same range. Okay, this you are not obliged to use one. Okay, you can use 2, 3, 4, 5, but you just do not use 7. Okay, 0.7 is reserved to the analyzer. Okay, so this is the range, must be the same range. Okay, this one at the end you can use anything except 7. 7 belongs to the analyzer. Okay, and then of course here, before that, let's say, okay, just one moment, let me share something. Yes, of course. Yes, you can manually unclog the flow cell. Yes, when we reach the fluidic sequence, okay, I will explain in the troubleshooting how to unclog manually. Okay. Of course, because even for the unclogging, you have to be careful. Okay, there is only one working way that I will explain to you later when we reach, maybe to tomorrow when we reach the fluidic sequence. Okay, I will teach you the right way to unclog it without damaging the flow cell itself. Okay, let me share something. Okay, guys. So normally for the software, okay, if you install directly the software that came with the analyzer, okay, software pack or CD, here of course you can directly install it and access to the operation software, okay, or the analyzer or the user interface. Okay, let's say the software that came with the analyzer is 1.29, for example. Okay, and of course maybe after 2 years in stock you will install it, and we already have a recent version, let's say 1.35. Okay, for example, here it is mandatory to upgrade also the analyzer software. Okay, software of the analyzer, it is mandatory. Otherwise it will give you, once you open the operation software, it will give you how do you say, like software mismatch. Okay, as I told you before, we have from the PC, we have the PC and the analyzer. Okay, the analyzer, even though it doesn't have any LCD or something, but it has its own operation software, okay, that we call the analyzer software. It is the firmware of the boards and so on. Okay, it contains the firmware of the FPGAs, for example, the chips inside, plus the operation software. All right. Okay, guys. So as I was saying, so for example, if it came with a CD 1.29, and then you want to upgrade to the latest version, let's say 1.35 or 34, here it is mandatory to upgrade also the software of the analyzer. Okay, can you see the screen now? Radwan, can you see the screen? Okay, good. Okay, so guys, as I told you, for the PC side we have the software, okay, the PC software, and then we have the analyzer software also. Okay, what does it have, this analyzer software? It has the operating system of the analyzer itself. It is Linux based. Even though we don't have LCD, we don't have anything, but it is there because we have a CPU module, CPU board embedded in the main control board. And of course, we have firmware for the chips, for the FPGAs, for example, let's say autoloader board, the driver board, and so on. Okay, these two guys here need to be compatible. Okay, compatible. So let's say here, maybe the analyzer came with 1.29 version. Okay, if you install directly 1.25 in the computer, if you install 1.25 in the computer, for example, it will not work. It will say it will say software mismatch error. Okay. All right. So for the connection, I told you always 10.0.0.7. This is the IP address of the analyzer. Okay. So you can use any address you want except 7. So let's say by default you can use 10.0.0.1, for example, and the subnet mask 255.255.0. Okay. How to test if the communication is good? You can use ping directly and ping 10007 and see if the instrument replies to you or not. Okay? If the instrument replies normally, but the other analyzer, but the operation software of installed in the computer doesn't recognize the analyzer or it's saying no communication here, but the analyzer replies here, it means that there is a mistake in the setup file. Okay, so you go to the installation folder of the analyzer, to D, and then check setup.ini file. Okay, and make sure that the IP address of the analyzer is 10007. Okay, because it is the setup ini file that tells the software on the computer where to find the analyzer, which address. All right. Okay, let me go back to the PPT. All right. So we are assuming the same versions. Okay, so here directly we access, because as I told you for the PPT, just highlighting the main points. Okay, this is the engineer password for hematology. This is the administrator account. This is initializing. You would see this. This means that the communication is successful. Here, select no to initialize liquid system. Of course, here it's saying if you want to skip fluidic initialization, just say no to prime and so on to get ready the fluidic system. Okay, and here if you have skipped it, and here you access menu, services, maintenance, replace reagent, and click replace all reagent to prime to prime the reagents. This is for cleaning. Okay. And then when you replace this reagent, of course, if you skipped this procedure, this one, then do this one first, prime it, and then initialize the liquid system. Okay, this is just to initialize, to do the startup sequence, priming and so on. All right, this hemoglobin blank voltage adjusted to 4.5 approximately. All right, this is very important. Just play with this game. This one, what it will do, it will just adjust the blank voltage. So there is liquid inside the WBC path. It will turn on the LED and it will measure the voltage. It should be around 4.5. All right. Now, the background test. Okay, select closed tube whole blood, CBC plus diff. Load a tube with long adapter into the compartment and close. Okay, here it will just do some air aspiration. All right, and this is the requirement for the background test. All right, when we reach the fluidic, or maybe the last session, we'll focus more about troubleshooting this background or samples and so on. Okay, if you have, for example, high platelets, what is the cause? Hemoglobin not good, and so on. All right. For the background test, also the diff pulse data length, because here we do not see it. Here we focus only on the CBC, because these are the CBC parts: absolute value of WBC, RBC, hemoglobin, hematocrit, and platelets. But for the differentiation for the population, how we know that it is good? For the diff pulse, it shouldn't be less than 300. If more than 300, here probably, most probably, that you have some foreign particles coming with the sheath. Okay, or maybe some air bubbles. That is the only thing. It is not electrical interference. It is very highly unlikely to get some interference in the diff path or in the diff channel. Okay, then you do the repeatability test. This is also very important, the repeatability test. Here, what do we do for the repeatability test? We do 11 repetitions and we omit the first one. Okay, so we start from N2 to 11, okay, to get 10. And then we'll see the specifications. All right, this one also I will explain in detail. For the repetition, of course, we take into consideration the CVs except for the differentiation. For the diff, we take the SD instead of the CV. Okay. So this is the CV requirements for the CBC values, for the whole blood and for the pre-dilution. And of course, this is also the condition, because maybe if it exceeds this interval, this CV will no longer valid. Okay, this is just a normal sample. This one for the particle test, but now, as I told you, normally I'm not sure, but normally it's no longer available to order or to purchase. But if you still have it in your stock, you can use it. This is just basically plastic cells, okay, of 7 micrometer diameter to check the forward scatter and the SS scatter caused by these cells. Okay. It is also a very good tool to troubleshoot diff-related issues, because these particles you will eliminate the reaction cause. You know, because this one I do not need to lyse or anything. Okay, it will not be affected by, let's say, by the reaction temperature or by the lysing, okay, by the chemical. So this is directly, if this one is not good, it means you have a problem with the focalization, with the sheath directly. Okay. So here we do the particle test in the optical. Here we put the pick one target. What is the target for FS? What is the target for SS? Okay. This one also we'll see it in the troubleshooting. It is very detailed in the service manual. If you want to use control or fresh blood, of course, here we use particle 2. Okay, particle 2 is the control all the blood. This means blood. Particle 1 is plastic material. So as you see here, the gravity center for the FS gain is 18, let's say, plus or minus 2, SS 1.4. Okay, so if I go and put this target here, okay, it will calculate the gains. Okay, it will increase the gain to get this target. Okay, and of course the gain, it can go from 0 to, okay, more than 0 to maximum 255. But what is important about this is the max width. Okay, the max width of the impulse, or all of the FS or the SS created by this particle. Why this important? If the width is too high, it means that your cells are not properly focused. Okay, so here directly you know that you have a problem with the focalization, with the hydrodynamic focusing, so with the sheath, okay, or maybe with sample injection. Anyway, this one means not properly focalized. For the FS and the SS, if both FS and SS are very low, you mean that it means that you need maybe a very big gain to attain these values or to reach these values, or maybe the CV is out of range. Let's say it gives you the gain of let's say to get this target 1.104, you need maybe a gain of 253. This is out of range. Okay, so this is probably that the SS photodiode is tired, okay, or has aged. If both are low, here either the flow cell is dirty, especially from the external side, or the laser current is relatively low. Okay, and here in the troubleshooting, I will give you a trick before you replace the laser control board. There is a potentiometer to adjust to increase a little bit the current of the laser to compensate for the aging of these photodiodes or for the laser itself. All right. Okay, so for the mechanical part, for the mechanical adjustment, so of course you need to check and confirm or adjust if necessary the sample probe position. So what do we have for the sample probe? You have the diff bath, the analog percent position, the autoloader percent position, this one on the rack, okay, to make sure that the probe is well centered when it pierces the tube. And this is for the closed tube percent position. This is the manual loading position, okay. This is for the manipulator also. It's very important. The manipulator is the gripping of the mixer. It is the mixer. It is the part that grab the tube and mix it. This one also, it needs to be perfectly centered. Otherwise, when you install it, if you do not check it, after 1 week maybe or 10 days, it will break, okay? Those two metallic or of the gripper, one of them will break, okay? Because each time it grabs the tube is not centered, then it will hit the tube, okay? Till it breaks. All right? This is for the mix mechanism self-test. Okay, you can initialize it, move it in the X direction, in the Z direction, mix sequence, and so on. Okay, so this is for the autoloader adjustment. Okay, it is mechanical adjustment. This is the closed tube percent position. Okay, it needs to be perfectly in the center. And here, of course, for this one, as you see, why we need these mechanical positions here, or mechanical adjustment, like manual adjustment with the screwdrivers, because here we can only move our probe in the Y and Z direction, but X direction is not available. All right. Okay, so here you can remove, you see, and move. For the analog position piercing also needs to be centered. Here you can put a piece of paper, okay, or you can put adhesive tape on the tube to make sure that it is piercing exactly in the center. This is the gripper or the pincher. Okay, this is the same thing. The gripper also need to be centered when it comes and take the tube. As I told you, if it is not centered here, after 1 week, maybe 10 days after installation, one of them here will break, okay, will separate, and you will have to replace it. Okay. This is quality control settings. Okay, you can read the file directly or set them manually. You press start. Of course, guys, here, it is important just to keep in mind, you do not run the QC as a normal sample, okay? Because the analysis algorithm is not the same, all right? Because the QC is not entirely human blood, okay? It has bovine origin. So be careful about this. If you run it as a sample, you will not get good results, good scattergrams and so on, okay? So just run it from the QC part. This is just the Levy Jennings. Okay, for the calibration, you require to be administration because it is the responsibility of normally of the operator or of the doctor. So you can use calibrator, you can use fresh blood, or you can directly calculate your own target factors and then type them manually directly. Okay. These are the calibration factors for the pre-diluted and for the whole blood. This is for the fresh blood also. Just put the targets and calibrate. This is to replace the reagents from the maintenance. What does it mean replace? It means prime, okay? This is to clean. WBC bath cleaning, RBC cleaning, diff bath cleaning, flow cell cleaning, sample probe cleaning. This is for maintenance, okay? You can unclog, zap apertures. This will apply high voltage, high AC voltage to burn all the remaining of the membranes of the cells on the electrodes. And this, why do we need this one? Maybe you will see some increase in the MCV or in the MPV. Okay, this is an indicator of this phenomenon. It means that we have initially you have some impedance caused by those membranes, okay? So here, when you get the total size of the cells or the mean size of the cells, Here, of course, you will get the size of the cells plus that impedance of the membranes stick to the electrodes. Okay, so here you will get some increase. You will get some right shift in the histograms. So here you can try up apertures to burn this. Okay, this is flash the apertures. Probe cleanser soaking. Okay, here you use probe cleanser. Diff bath soaking the WBC bath, RBC bath soaking, flow cell unclogging. Okay, and this is for the emptying of the bath. Okay, this is for whole device maintenance. You can do fluidic initialization. If you skip it for some error or something, you can come here directly and do initialize fluidics. It is startup sequence. This is clean fluidics, all the fluidics, and this prepare to ship. There is a procedure to drain, okay, put the eye water, drain to make sure. This one, if the analyzer will be stopped for more than 10 days or more than 1 week, it is highly recommended to do it. Because it will be clogged, and especially for the RBC bath and the flow cell, they are very difficult to unclog, very difficult. This is some self-test in case maybe you are troubleshooting some mechanical problems. You can do some self-test for the motors, say diluent syringe, light syringe, sample injection, and so on. This is the self-test for the valve. It will turn on for maybe 3 seconds or 2 seconds and then turn back off again. Okay? But guys, when you test, remember very important details. Here, what do I test? I'm testing the solenoid of the valve. As you know that each valve has a solenoid part and that plastic or the valve part, all right? So if you have some clog or some issue with the membrane of the valve itself, for the valve part, even if it clicks, it doesn't mean that it works perfectly. So here you need to check manually with the syringe and the tube, okay? This is some other tests, okay? This one, tube filter, volumetric tube, we do not have it, this one, okay? This one you can check WBC aperture voltage, RBC aperture voltage, and the count time, the counter, just like the car, how many cycles. Okay, for the shutdown procedure here, shutdown, it will ask you to put probe cleanser and it will shut down. Guys, do you have questions about the installation part? Easy. Emmanuel, do you have a question? Emmanuel, you didn't sign up the attendance sheet. Guys, if you haven't signed the attendance sheet yet, please do it. Thank you. Yes, Emmanuel. This one also will explain it. Okay, how to use, because now I know that the standard particles are not accessible, I will teach you how to calibrate with the fresh blood and also with the BC5D QCs. Okay, it is done the same way as the standard particles. All right. Okay, let's finish one PPT and then we'll call it a day. How to, okay, I will share a link now. Open this form, this online form. Okay, write your full name, company name, and email. Okay. All right, so this is for the software installation. We already seen it. Okay, this is the special information for each of for each test. What do you have here, like information? All right. So we have the AGB blank voltage, the measurement voltage. Of course, the voltage measurement voltage is always lower than the blank voltage because here we have higher absorbance. All right. This is for the diff pulse. Okay. The diff width, the FS mean width, WBC path, RBC pulse, and the platelet pulse. Okay. So here we have very important information here. The diff baso channel particle ratio. Normally, this one theoretically should be as close as possible to 0.9. Okay, what does it mean? Here we have the diff particles without ghost. So let's say 6,483. What does this mean? It means these are the particles that entered the flow cell and were recognized as WBC populations. How the instrument recognizes them? Of course, in the scattergram, we have the theoretical positions or regions for those populations. As we saw in the scattergram, we have the lymphocyte, monocyte, neutrophil, etc. So any cells that has coordinates FS and SS in that region, no matter lymph or mono, it is considered as WBC cell. Okay? And here we have the diff particle total. Here, it is the total particles that entered the flow cell. Okay? But of course here, not all of these particles are WBC. So here you see 31,000. This excess, mostly maybe some RBC ghost, debris, platelets, and so on. Okay? But among this, only 6,483 recognized as WBC because their scattergram, their FS and SS information fall in those populations region. Okay? This is the basoparticles without ghost. Also the same thing. What does it mean? It doesn't mean that all of these cells are basophile. No. It just means the total numbers of the cells that were recognized as WBC in the impedance channel. It is 8,215. All right? For example, this is not fixed, okay? It depends on the sample. And this is the basoparticle totals. It means all the particles that generated some impedance passing through the aperture. It is 8,300. So between this one, this total particles, WBCs without ghost, this is the WBCs actually, in the impedance channel, or the WBCs in the diff channel should be close to each other. So normally the diff, when I take this one, I divide it by this one, normally I should get something close to 0.9. Okay, this is the good one. Now, if the diff particle ratio, is far, what will happen? It will gray the scattergram. It will not color it. Okay, and this is indicator that these two particles are very far from each other. Okay, and this one also, when I divide it by 0.9, I will get the absolute count of the WBCs. This is the ambient temperature during the test, diff temperature, and the optical system temperatures. Okay, and this related to voltage, aperture voltage, vacuum, and so on. Okay, so it's very important. During the troubleshooting, I will choose some of the abnormal result, and we'll see how reading or understanding special information can help us in the troubleshooting. Okay, in finding what is the problem. Okay, this is for the data backup. You can export the data. You customize the printing template, click customize, and you will get your print template. Click service, password SE space S700, and you will get your printing template. Okay, you can add, remove, customize it as you want. All right. Now to upgrade the analyzer software. For this upgrade, what does it mean? Like the example I gave you during installation, or maybe you just want to install new software. When you finish installing new software on the analyzer, on the computer, then you need to upgrade also the software of the analyzer. What does it have, the software of the analyzer? It has two parts. It has the operating system, the software of the analyzer itself inside the CPU board, and you have also the firmware for the FPGAs. So you just click on the analyzer upgrade here. Okay, enter your service and password, your service account and password, and then you select the upgrade package. It contains two files. It is step 1 and step 2, and then you will do step by step. This is there is a service tool also. This one, what is the service tool? Tool for service engineer. This one. When you click it, you get this one. Okay, you can back up. Okay, you can export special information, database, restoration, the IP configuration of the analyzer, and so on. Okay, this is the host default IP. The host means the analyzer default IP address. Okay, this is for the alias communication from the software. Click communication, the interface setup. This is the IP of the alias server. Okay, and this is the port. You can use 5100, for example, and that's it. Okay, guys, let's take 5 minutes if you want if you have some questions to answer regarding what we saw today. Okay, thank you, Emmanuel, for signing. Okay, guys, if you don't have any more questions, we can finish today's session. Okay. Ordovan, do you have a question? Ramadan, do you have a question? Sophia. Okay, good. Okay. So guys, have a nice day. See you tomorrow. Bye bye.